My name is Bob Elliott with J-KEM Scientific, and what I want to demonstrate today is our precision syringe pump. The system really consists of two parts. There's the hardware components of the pump itself, and then there's the software components. But I'm going to start with the hardware components first. You can get the pump in many different configurations. What's in front of you now is a dual position pump because it has two independent syringe pumps on it. You can buy a single position pump, which would have only one module on it. As I said, this is a dual position pump, but it's routine that we sell 4, 8, 16, or even a 32 position system. So you really can customize it to anything that your application needs. Regarding the pump itself, it has a 100% inert flow path. It's either a glass syringe and it's a Teflon valve, so you can dispense any aqueous solution or organics or strong acids. We even have customers who dispense concentrated sulfuric acid from this. The syringes themselves, as I said, are glass and Teflon, and they come in a variety of sizes, anything from a 10 microliter syringe up to a 50 milliliter syringe you can put on here. In this case, I have this fitted with a 10 milliliter syringe. The distribution valves are fully addressable by the program, and they come in 3, 4, 6, and 8 positions. And what that means, since I have 8 position valves on here, I'll talk about it. What that means is any of those 8 positions could be inlets or outlets. And so for example, you could say you could have 6 different reagent bottles and specify 6 of the ports as inlets and 2 of the ports as outlets, and have the first outlet going to one of your reactors and the second outlet going to a second reactor. Then under program control, you could say to go to port A and withdraw 25 milliliters of something and add it to my reactor. And then you could say go to port B, which would be your second solvent, withdraw 5 milliliters and add it to my reactor. And then port C and D and so on like that. So any of the ports you can use for addition or withdrawals completely under program control. What's unique about the pump itself is it's high resolution. So from the top of this syringe to the bottom of that syringe, there are over 3 million steps, which give it extraordinary precision. All of our syringes with any size have microliter accuracies in their dispenses and their withdrawals. But what's even equally important with that is the very wide speed range they have. If you put on a 10 microliter syringe, you can get down to delivery rates as low as 3 nanoliters a minute. And if you were to put on a 50 milliliter syringe, you could get up to flow rates as high as 750 milliliters a minute. Even with the 10 milliliter syringe that I have on here, the flow rate with using just this syringe can range from 3 microliters a minute up to 150 milliliters a minute, which is a flow factor of 50,000. And as I said, you can get them available in single or dual or mini sizes. I'm going to first run a demo using just a single pump so you can see how they add. And once you see how the single pumps add, then you can watch and see the difference between a single pump and a dual pump addition. So for this experiment, I'm going to run it fairly quick. I'm going to ask the 10 milliliter syringe to deliver a total of 25 milliliters at a rate of 25 milliliters a minute, so the experiment is going to go fairly quick. And when I start it, the syringe initially fills, and then once it's full, it will start to deliver. So you can see it's delivering at my requested rate of 25 milliliters a minute. And it'll continue to do that until it's empty. And when it's empty, it shows another key feature of J-KEM's syringe pump system. The pumps automatically refill. So I can ask a 10 milliliter syringe to deliver a total of 25 milliliters. Now that it has just delivered its first 10, what it's doing, it's going back to get 10 more, and then once it's full, it will resume its addition at the exact same rate. And now this is going to show a key feature right here. So the first one is all the pump systems automatically refill, so you can deliver any volume from any system. But watch what happens when it needs to refill again. Right now it is dispensing at the requested rate of 10 milliliters a minute. But when it needs to refill, the dispense will stop. It has to, because there's only one syringe. Once it's full, it will resume its delivery. In most cases, that's not really important. For example, if we were dispensing at a rate of 1 milliliter a minute, which might be a little more practical, then you would deliver for 10 minutes at 1 milliliter a minute. The syringe would then have to stop for about 6 seconds. It usually takes 4 to 6 seconds to fill a syringe. So it would stop for those 6 seconds while it refilled. Then once it was full, it would resume its delivery. In most cases, that short pause in refilling is fine, and so most chemists can use the single position syringe pump. Some people cannot. Sometimes some applications need really, truly uninterrupted flow, and that's what you can achieve with a dual pump system. So for this run, I'm going to do a dual pump addition. I'm going to increase the volume just that it delivers just a little bit more, so we'll have time to watch it. And then I'm going to run the exact same experiment. In the dual pump system, both syringes, of course, are going to fill. Once they're full, syringe 1 starts to deliver at the rate I requested, 10 milliliters a minute. And it'll do that until it's empty. Now, the important point here is watch what happens when syringe 1 is empty. So you can see there's consistent flow right now. And what happened was, as soon as syringe 1 was empty, syringe 2 picked up delivery, so there was never any break in delivery. And then while syringe 2 is delivering, syringe 1 refills. And in this case, as soon as syringe 2 is empty, you'll see there's no break in delivery. Syringe 1 starts to deliver. And this reciprocating syringe action can continue for as long as you need. In this case, I've asked it to deliver 35 milliliters, and it'll deliver 35 milliliters with absolutely no break in addition. So there, the syringe pump just delivered 35 milliliters of continuous addition. So the key points in the equipment side of this is that the pumps are completely inert, nothing but glass and Teflon. They have an incredibly wide flow range, from flow rates from 3 nanoliters a minute up to 750 milliliters a minute. An extraordinarily high precision. That, as I said, that syringe is divided into 3 million steps. So even with a 10 milliliter syringe, you can reproducibly add microliters of solvent. And now I can focus on the software portion of this. The software, there are certain standard programs. This very first one is a timed addition, and that was the program that I was running. So in the timed addition program, you can say what your inlet port is, and in this case, I could have picked any of my 8 ports. You specify what your outlet port is, you enter the rate of addition, and then the total volume that you want to add. You can also enter a fill rate, and most of the time, fill rates aren't important if you're using just a standard aqueous organic reagent. But if you're using something very viscous, like a monomer, then you can enter a fill rate low enough that the syringes fill appropriately. And that's the first standard experiment. The second one is called a multi-reagent addition. And in this one, you have an Excel-like table where you can actually create a program. So I can say I want pump 1 to go to port A and then fill and then go to port C. I want it to deliver a total of 12 milliliters and I want it to take 35 minutes to do that. I can even specify after that delivery, you can enter a pause of a certain amount of time, and then after you've done that addition, I want pump 2 to go to port D, use that as its inlet, and then the outlet would be port F. I want it to withdraw 1.25 milliliters. I want it to add that at a rate of 0.001 milliliters a minute. And so I can set up an Excel table with as many as 16 steps telling which pump to go to what port and fill with reagent, and then to go to what port and dispense. The next experiment is called concurrent addition. And in this case, because I have 2 pumps, I can set up something similar. I can tell pump 1 create an addition program for it, which would be what port to go to and fill from, what port to dispense to, the volume that it needs to dispense, and then its speed. So this would be an independent program for pump 1. I would set up the same program for pump 2, or a different program for pump 2. But now when I start this experiment, both pumps will simultaneously and in parallel run their individual independent programs from one another. You could use that, for example, to add 2 reagents concurrently to a single reaction. For example, if you were doing a polymerization reaction, maybe on pump 1, you might want to add 200 milliliters of a monomer in an hour, and on pump 2, you might want to add half of a milliliter of a free radical initiator. And you can do those in parallel with one another on that experiment. This experiment, actually the parallel addition experiment, what you can do if you have a single pump, you could use that single pump to add to multiple reactors. So with a single pump, you could say on port A is reactor 1, on port B is reactor 2, on port C is reactor 3. And I want you to add 20 milliliters of my reagent at a rate of 1 milliliter an hour to reactor 1. I want you to add 15 milliliters of the reagent at a rate of 10 milliliters a minute to reactor 2. And then you could have a different volume at a different speed for reactor 3. And so a single pump is able to add a common reagent or even different reagents to multiple reactors. JKEM has tried to think, and most of the time these programs are so versatile that almost all users, they'll be the only programs you need. But we do have users who have truly unique needs in their research. And in this program called Program Builder, there's a list of every single command that a syringe pump can do, and you can build your own program. So for example, I could say I want pump 1, first of all, to go to port 4. I want it then to set its speed to 50 milliliters a minute. I want it to fill the pump, and then once it's full, I want it to go to port 2. I want it to change its speed to 1 milliliter a minute, and then I want it to dispense 2 milliliters. I can continue with these programs, and you can have thousands of lines of code. The program, you can tell it to put in delays, you can put in conditions. For example, I want you to deliver 50 milliliters of this reagent at a rate of 1 milliliter a minute, but if the temperature gets above a certain point, I want you to stop the addition, or if a switch becomes open or closed, I want you to change your addition rate. We have users, especially for solid phase extractions and for solid phase synthesis, their programs can get to be thousands of lines of code long. Basically, the program builder gives you the freedom to literally string together any syringe pump action into your unique program. JKEM also has a policy of if you have a unique program, you can tell us at the time of purchase, and we will write that program for you at no cost and include it in your software. There is one more feature with a timed addition. JKEM's pumps are designed to work with other pieces of JKEM's equipment. So for example, if right now I plugged in a JKEM temperature controller, an image of that temperature controller would appear right here on screen. And now, since I can measure the temperature of my reaction, I can do temperature-dependent additions. So for example, I could run the other experiment I did in the very beginning and say I want you to add 50 milliliters of this reagent over the course of 1 hour. But if the reaction starts to go over 60 degrees centigrade, then I want you to slow the addition of the reagent. And if it actually goes to 65 degrees centigrade, I want you to stop the addition of the reagent until it cools down, and then you can resume the addition. So simply by adding a JKEM temperature controller, now you can do temperature-dependent additions. Also, there's a feature that you can put in these pumps which will allow you to attach a pH probe. And now you can do temperature and pH dependent additions. So with the pH probe, you could do exactly what you did with the temperature probe. You could say, I want you to add 50 milliliters in an hour, but if you go above or below this pH, I want you to stop the addition. And also, the pump then becomes a pH stat. Now what you can do with it is say, well, I'm running my reaction, but my reaction needs to be run at a very specific pH. You could enter, I want you to maintain that reaction, for example, at a pH of 5.2. So the reagent you would put on the pump at that point, for example, is acid. If your reaction produces base, then the reaction would run itself. The pump would continuously monitor the pH of the solution, and it would add small increments of acid to maintain the pH at exactly the pH that you requested. And so that is JKEM's Precision Syringe Pump. It's software that comes with it at no charge. JKEM offers, remember, the option of one custom program at no charge. Thank you for your time.